So Mitch, we can start. We are ready.
Okay, great. Just okay, so let me share my screen here. So thank you again, everybody, for joining the second session. So let's go over a bit what we did yesterday and what we're going to be doing today. Okay, so I'm sharing my screen here just to show you what we kind of went through yesterday. So we went through basically a general overview of the different resources that you guys have, the roadmaps, the ground station, different components, an overview of the resources. So we set up the resources on your ground control PC, and we did an overview of Symlink and Quark, and we'll be talking about Python today in the second part of today. So this is not quite done yet. Now using, for the most part, what we did was running the hardware test in Symlink. So you guys have done very well in understanding how to target the Q car using the core controllers, right? So using the Symlink model to build and deploy the real-time core control. With the basic IO example, we read the CSI cameras, we did the Intel RealSense camera, and then we did the interface to the RP LiDAR, right? So now touching base on this LiDAR, because we had an issue with the update rate yesterday. The update rate was quite slow. So we ran some tests after the session yesterday, and it should definitely be a lot faster. So I think in today's session, what we can do is, how many Q cards do you have? Do you only have one or two?
Yeah, one Q car.
One Q car.
We have one Q car. Yeah.
Okay. Okay. So it might be an issue with the cable not being firmly connected or something, but this is something that maybe at the end of this session or tomorrow we can maybe look more into a little bit for a bit more troubleshooting. But I don't want to spend too much time on that because we have a lot of other applications to get through that don't depend on the LiDAR. But I just want to make sure it's not. So we can run a few more tests on your LiDAR first to make sure that that Symlink model is properly configured. And if it is properly configured, then we'll look at the cable, make sure that's well connected, and we could look at a few more things. But we could do that kind of apart from the training session. So I could touch base with a few of you on that want to participate in that troubleshooting for the LiDAR. Does that make sense?
Yeah, fine. Correct. Totally.
Excellent. Okay. Okay. So so because it is working, it's just updating slowly. It should definitely be faster, but it might be the update rate of the plot. So we'll look into that. Okay, so today we're going to start with the application. So yesterday we used Symlink and Quark to do the hardware test, right? So interfacing the different hardware components of the Q car, but they weren't really built around any kind of application that is commonly seen in self-driving vehicles. That's what we're going to do today. So we'll go through 5 of them. We're going to be we're going to do a manual drive. So basically using the gamepad on the ground control PC, you command the throttle and the steering to the Q car remotely, and it follows your commands. We're going to do 360-degree vision, 360-degree vision. We had some questions about that yesterday, how to use all the CSI cameras together. So that'll be that example. RGBD camera, lane following, point cloud generation. Then we'll switch gears and go to Python. So we'll make sure, first of all, that your Python is correctly set up on your PC and on the Q car. Show you how to connect and show you basically about the QCar Python connectivity, stuff like that. And then I'm hoping to run at least some, I don't know how much we'll go through, but it's okay because we have tomorrow as well, but we'll try to get through um, hopefully all of these Python hardware tests first. So I think this should be manageable for today. Any questions about that? Okay, so I'm just going to go through the different applications, give you a background, and then of course you guys will get to have some fun and run all these. So like I said, 360 degree vision is where it is using, I'm gonna make this a bit bigger. So 360 degree vision, this is where it captures the images of the 4 CSI camera and basically stitches them together, displays them all in one display volume module. Manual drive is, like I said, interprets the commands from a gamepad, right, control, and does that to command the Q car. Point cloud generation, this uses the LiDAR, so we'll see how well this is going to work. It should work, it'll just be probably slower. But this does like self-localization. But instead of just doing a polar plot, it creates a 2D map. And we'll do RGBD imaging, which is basically some image thresholding exercise where you use that to detect the stop sign. And the last one we'll do is lane following. So that is when the Q car basically follows the line of on your roadmap, right? It's a very one of the most popular examples, I would say. So 360 degree vision works as follows. So you basically you're using the capture image block that we saw yesterday. So yesterday we saw that, but you would only be enabling one of the blocks at a time. So in this case, they're all operating in parallel, and then we put them together. We kind of merge the images together and put that in display block, and then you get a video display similar as shown below. In the LiDAR point cloud generation, again, we saw something similar yesterday, but basically it was only the top portion of this model where we just capture the LiDAR and display it on the polar plot. So this is basically the body frame. But the point cloud, what it does is basically takes the distances and headings and populates a map, right? So you populate an XY map. And so it'll find all the XY points using the LiDAR data, and then it converts that into pixels for the 2D map, and then you can adjust the decay as well to change the map update rate. So we can look at that. RGBD imaging. So actually, just to show you before I branch off here, I'll just show you the LiDAR example. So this is the LiDAR example. Actually, I have a in here where you have your body frame and the view compression block. So basically you capture the LiDAR data, distances, headings, and this is what we did yesterday. And then the point cloud, basically you get the distances and headings and you create a map as shown here. So you get something like this. Right, so distances and headings go here to find the contour, and then you convert that into pixels and it goes to your map. So that's basically how this works here. So just to show you this very quickly. So I have a QR connected to my laptop right now. So if I show you this, so this will show you basically, this is the plot that you saw that we're using yesterday. So that's your body frame. And I can't really swivel my PC too well, but I have the QR sitting basically just in my desktop. And you can see this is the polar plot that's being updated, and then it has the map here. So you'll get a map drawn out similar to this. The last one would be RGB, not the last one, but the other one that's of kind of a segue before you're doing lane following is RGBD imaging. So this uses um, your Intel RealSense camera. The Intel RealSense camera has quite high resolution as well. So here you see the stop sign. This is the raw image, and then you want to filter all the image just to see the stop sign. And you can do that using by adjusting the minimum and maximum threshold values of the image compare block. So you're capturing the image using the this system here. So if we show the example in more detail. But as you can see here, so you're capturing the RGB imaging, and then you're displaying that, which is shown in the top right. Then you want to find the stop sign coordinates by using the image filtering. So this is done using the by adjusting the minimum and maximum saturation and values. I'm going to talk about this a little bit more because this may be unfamiliar to people. Um, Usually what's used for image thresholding is sometimes RGB, but HSV is becoming more popular now. Personally, I've used HSV more now because I find it a lot easier to use, but it's a different color scheme a bit. So um, and if I show you this, I just want to. If we look at the RGB, it should show you. So this is the manual here where yeah, that's not what I'm sure, but oh yeah, here's the hue in here. So you can see the saturation. You have blue, green, and red, but it adjusts on the hue that you set, your saturation, and your value. So that is the HSV values. We have a little bit more information if you look under concept reviews and you look at image filters. Let me see here. I just want to open up because I want to show you more about how the yeah. Here's the RGB. So this is part of the concept review color displaces that you have on your ground control PC as well. So you can open this up on your ground control PC if you want. But these are the RGB colors that people are primarily familiar with. So you know the RGB image, the red plane, blue plane, you can do that. And then you also have HSV values. So that is what is shown here. So you have hue saturation values here. Um, so the hue um, and so, so it's a little bit different, but it's like a light intense information, right? So and this is basically how it works. So I think the best thing would be if you look at the manual, you'll kind of see how to adjust the colors for getting for filtering out a certain image, right? So when you're looking at the red stop sign, you want to adjust the minimum maximum hue and sorry, the minimum saturation and the maximum saturation, as well as the minimum value and the maximum value to get the red here. So V is here, and then you have the saturation here to get the red color. So this is basically your reference here that you can use, right? You can use the hue color wheel in here to give you a better idea. But we'll go through this exercise and be more evident. You can tune this on the fly. So you can tune this on the fly in order to filter out this image and know whether or not you're wrong. But if we look at the model here, so here is the actual model. And so you capture the RGB image, which you already seen before, right? So you have the RGB, the video 3D capture block is set to get RGB for the stream. And the second video 3D capture block, the stream type is set to depth. So this is getting the depth and image data. So you get this to find the stop sign location in here. This is where you adjust your threshold, right? So the hue stays at 0, but the saturation and the value for that HSV color wheel will change, right? So you change the minimum values and the maximum of these values, right? So note that this is the minimum saturation, the minimum value, the maximum value, maximum saturation and maximum value. So you adjust these in order to filter out the image. This gets passed, and then once you do that, it goes through the image compare block. So it takes the raw image, goes through the image compare block, and basically filters out the unnecessary stuff and just gives you the stop sign or whatever other object you're trying to detect. Then you can use the image find object blocks to give you a location. So that'll give you basically the center of the image. So once you get that, in pixels, you can convert that into an actual distance. So this goes here. So you have the center of the blob that you're detecting in pixels, and then you can correct for that. You can adjust it to get a distance measurement. We could talk a bit more about this, like once you guys run it and kind of feel comfortable with how to use it, then we can take a deeper dive and explain more about the ins and out of the model. The other one is manual drive. So manual drive is basically what we're doing is you should have a gamepad with you. I hope you have it with you here on the ground control PC. It's like a little joystick, like a gamepad used for video games kind of thing. It looks like that, but you can use it so you can capture the gamepad commands, and then it basically interprets the commands used, for the throttle and for the thrust. And so it maps those commands that you use on a gamepad and goes to the QCar IO. It also does some stuff for indicators and lamps. So as the Q car is moving around in the space and depending on different commands, it'll change the different indicators and lamps automatically, right? So if you're turning right or left, it'll have the blinkers on, for example. If you brake, it'll put those lights on. It also monitors the power and has a speed estimation. So we had a question yesterday about how to estimate the position. This is very similar, but it's estimating the speed. We're going to see this in a couple of models. So the speed is basically very similar to getting the position. The position is very similar to getting the speed. So this way, basically how it's done. So using the Logitech F710 gamepad that you should have, you capture the data using the game controller block inside here. So once you get the steering and the throttle and whatever buttons you press, you interpret those accordingly. So then you can send a motor command directly to the Q car and also the steering command to the Q car. This is where you do your decision, what's called a decision and planning unit. So this basically changes the indicators and lamps, according to the commands you're giving. Here's your interface. So the QCar IO, you're quite familiar with this now because this is kind of what, you saw different models that were interfacing to the hardware of the Q car directly, right? So this is basically what this does here. Car. And then you can monitor the power and the speed. So when you're using the gamepad, I'll get to this later, but this is of course in the manual, but your left button, you need to press that down in order to arm it. Um, so you need to press the left button um, down in order to arm the Q car. Then your left stick is used for steering, and then the right throttle is used for to move to drive the robot, the Q car. I'm just going to open up the small really quick. So this is it here. So you can see here the gamepad. Again, these are all cork blocks, right? So the game control block is what captures your the raw data from your gamepad, and then you interpret those to give you your steering and your throttle, and whether you want to arm it and whether or not you want to go reverse. So it commands those, and this is basically doing the interpretation here. So your motor commands and whether or not you want to arm it forward or backwards. This is where you set the different lights, right, according to your commands. And this is your hardware I/O. So this is your motor command, and your indicators are all being applied to the hill right block. So you've all seen this yesterday. So the command conditioning here is just smoothing out some of the direction and the throttle commands being given and doing any calibration required. Then when you're reading, this reads the encoder counts directly, and it filters it and gets the derivative of that in order to get the motor speed. You get the battery voltage and the motor current to monitor the power, and this goes into these blocks here. Are there any questions so far? Okay. So the last one is kind of putting a lot of things together. So this is the lane following and obstacle avoidance example. So this is probably going to be the last one we do. So in here is here's an image of the Q car on just an example roadmap that we had used a long time ago. But you're capturing the CSI dynamic using the CSI cameras to extract the lane information, right? So the CSI cameras are used with the concepts you learn from the RGB imaging in order to extract the lane, in order to isolate the lane and use that to track the road. The Intel RailSense camera uses the depth data and checks for any obstacles. So if it has an obstacle, then it'll basically either disable or enable the motor command. Now, the way it does this, basically, you're setting the thresholding with HSV, just like you're doing for that for the image filtering example that you did before. So when you do the RGBD imaging example, you're going to do the same thing for you do this exact same thing here, right? Except in this case, before you did HSV, you adjusted the HSV values for stop sign. This time, you're going to adjust them for the lane, for the following the yellow line in the lane. Then basically using that data, it'll once you filter out a nice image, then it'll extract the lane location, right? So once you get the lane location, then it can use that in its self-driving protocol. So you can command in here you have the Q car start or stop. So you decided whether or not you want to arm it, and you give your designated speed. So then you send your speed commands based on any obstacles being detected. So if there's an obstacle detected, then it'll stop it. If not, then it'll follow the desired speed that you have. Um, then it also implements the speed controller, right? So the Q car is not controlled on its own, right? The steering commands have the servo motor, so that's controlled, but the actual speed that needs to be done, using a PI controller or something like that. So that's what's being done here. You have desired speed, measured speed, and then it takes those, compares them, and gives the required throttle in order to achieve that speed. And again, we're using the indicators and lamps subsystem that we use in the manual drive in order to change the lights accordingly, automatically, depending on the commands of the speed controller, i.e. the throttle and the steering. Okay. Any questions about that?
Which up to how much centimeter the depth camera can accurately measure the distance?
Which camera?
Depth camera.
What are the distance like thresholds?
Suppose an object is placed at 10 meter, so a depth camera we can measure the distance of that object, right?
Yeah. So for that kind of information, go inside Quanser,
Okay.
the Quanser folder, go to user manuals, QCar, and if you go to user manual system hardware, this is where it gives you all the information, right? So in here, when you want to get all the camera information, like for example, here is the LiDAR, and here's the Intel RealSense camera, right? Which is, I think, this is the camera you're talking about.
Yeah.
So for the depth, in here, okay, so it gives you the depth range. Yeah, this just gives you the field of view. Okay, so if it's not in here, then you can go to the spec sheet for more information on the website. And this will give you the data. Actually, I think we had it here. So
So it's less than 2% at 2 meter.
yeah,
Yeah. Fine. Thank you.
yeah, yeah. I don't know all the specs by heart. Sorry, it'd be you have so many different components, but that's a good question. So, but yeah, in the user manual, I have data for that, for the CSI cameras, the LiDAR, and all of other stuff, and then it usually points to more information for the manufacturer spec sheets. Any other questions? Okay. All right. So I think now what we can do is you guys can get to try all of these out on your Q car, and I will guide you through it. So I'm going to stop sharing my screen here, and then you can share your ground control PC. And yeah, let's start running. Let's start with a 360-degree vision example and go from there. Excellent. Yeah, I'm ready. That's good you did that. It's always a good check.
ये खुद शिफ्ट कर देंगे इसमें इधर लेके वो दूसरा आपको कह दी इसकी जरूरत अभी So we are going with 360 vision, right?
Yeah, sounds good. Let's start with that. Yeah.
Fine. You go to the model setting. You can use the traffic light and then they're checking guys. Fine. So we configured the IP address and we are ready to monitor and tune. Should we proceed?
Yeah, go ahead. That's well done.
Okay. So we have
All right,
the
excellent.
360-degree vision now.
Yeah, so we had that question yesterday about if you can use all cameras together. So this is this shows you how you can do that. So this, of course, you see in a lot of kind of a lot of cars today that has that 360-degree vision as well, right? Yeah, some of the vehicles have this. So if we if you look inside the Simic model, and yeah, capture 360. So this is similar to what you saw yesterday. So again, we're using these Quark video capture blocks. So note that the CSI camera uses video capture, where the Intel RealSense, because it's RGBD, uses video capture 3D. So this captures video. So this is a video capture block that gets the image data from the CSI, and if you double click on it, then you'll see a couple of specs. The main one here is basically just the resolution. So we set the resolution to having 640 by 480 image. So if you go back to the main part of your model, then the stitch command in here, this uses the, so you basically have four images, right? Four matrices. And then this is a it combines them all using concatenate. So this is a mathematical operation. And then that goes into the 360-degree view. So if you go back to image 360, and then it displays all that here. If you go to display, then it has that display block, the video display. Note also that these are also like to save on the bandwidth of the model has like these are enabled subsystems. So the display and the stitching, they're all done in sync, and it's only when you gain new data from the camera. Because this model is set to run at 30 hertz. So if you look down at the fixed step, you can go to model settings, or you can just go down to the right side. Actually, that's easier. Yeah, just hover on there. It shows you that, yeah, the fixed step size is set to 0.003. So basically, in the solver, as we did yesterday, you can set the sample rate of the model. So it's set to be running at 30 hertz. So because it's running at that rate, then you can adjust it accordingly. Yeah. Any questions about this?
So we have a question. What is monitor timing?
Okay, yeah, yeah, double click on that. And that's the scope that displays the data. So what you have here is you have three things, right? So the first one, the yellow line, is the sample rate of the model.
Okay.
The blue line is your reference. So the blue line is the sample rate that you set it to. So in this case, it was 0.033333, right? So because it's 1/30, so it's 30 hertz. So your yellow line is your measured sample rate, and the blue line is your desired. So they're tracking well. They're all on point. The last one is the computation time of the model, which will vary, right? So that is a bit below the value, and that's the amount of time it takes to do a full cycle of the computation of it's the amount of computation of the model, right? The amount of so it doesn't involve the capturing of data, or if you have a DAC or whatever like that. It's just yeah, the computation time of the actual model. So that is below the actual rate. So if you look at the monitor timing block, that shows you the three how that's done. So sample time, again, this will provide you this measures the actual sample time of your model. Uh, The second one, QC get step size, is just a function. So this is actually a constant. It's QC get step size gets the step size that was set for your CMYC model. So i.e. in this case was 0.0333, right? So that's just the value. That's the reference value. So that's your target. The actual sample time is following the reference as shown in the scope. And the last one is a computation time. So that's the total computation time of the model because it's just in there. But you can use the computation time block to compute, for example, the computation time. You can use that in like in an enable block and find out what the computation time for like let's say you had an algorithm inside your CMYC model and you want to compute how intensive it is just for that algorithm inside your CMYC model, like inside its own subsystem block, then you can use a computation time block in order to calculate how much effort that block is, that algorithm.
Fine. Thank you.
No, it's a good question. No problem. Okay. If you're happy with that, then I think we can stop this example and we can move on to another one.
So now,
Well, I would recommend any of the last three. So, did you want to do another imaging, or you want to go and drive it?
driving. Yeah, okay,
All
so
right,
we
sounds
go with
good.
the manual drive.
Let's go with manual drive. Sounds good. And then we'll switch back to doing RGB. We can do maybe the LiDAR after. Okay, so yeah, go ahead, do that. Perfect. Sorry, do you have your joystick connected? Your
We
your
have
gamepad?
our joystick. Nice.
What's that?
Let us confirm it. Right. Okay. So Mr. Rahim says it's connected. He confirmed it, but we got some error.
Yeah, I see that. So go back to model settings because the model right before worked. So I'm just wondering if we entered the command properly. Yeah, 11. Okay. Okay, go to solver. Okay, go to code generation. Right. Okay. Okay, you can close that. That's okay. Okay, try to click on monitor and tune again. Okay, try this. Go back. Okay, let's look at MATLAB. Let's see if it generated any code.
Nothing.
Yeah, it's there.
Oh, sorry, our English. Okay.
I think it's having an issue maybe overwriting that. So let's try this. Let's try so go to your CIMIC model and let's clean up that code. So go to clean. Clean
Okay.
all. Yeah, clean all. Okay, now let's go back to now open up the console. So click on console. No, right, go back
Oh,
to Quark
sorry.
console.
Okay, fine.
Yeah, just open that. Yeah, that might help. And then now click on monitor and tune. Can you still ping it?
Uh, Let me try. Okay, so no, we cannot ping it. What happened?
Oh wait, you got the wrong address there.
Oh, sorry. Yeah, wait. 6, 11. Yeah, we can ping it. Sorry.
Okay, let's go back to. It might be something with the path maybe being too long. No, it can't be that. Okay, go back to Simlink. Click on if you go down above of it, go to manage target. Okay, if you go to models downloaded, maybe
Yep.
so select select those models.
Which model?
Just Control A.
Okay, all the models, fine.
Yeah, just remove them. Click on remove. Yeah, yes. Okay, close that.
Save and close, right?
No, don't save.
Okay, close.
It's not okay. And let's go step by step now. So in the upper left, click on the deploy button. No,
Yeah.
no,
Oh,
never use that. Deploy
okay.
and connect. Try to start. Hmm. Okay, in the meantime, let's try a different example to see if that works.
Okay.
Yeah, save it. Um, yeah, let's try RGBD imaging. Yeah.
Okay.
Okay, that worked fine.
Yeah, so we have the screen. Let me bring it here.
All right, so you got the cue card there. Okay.
Yeah.
This looks great, actually. They're very. You guys have a nice lab. Yeah, I was there 2.5 months ago or something in June.
Thank you.
Yeah, so but it's nice to see it all pretty much done. Do you guys have a stop sign handy?
Stop sign. Yeah, we are just testing. Stop sign. No, stop sign. Now sign. Up. Which I think think it's gonna take 2 to 3 minutes. So in the meanwhile, if you want to explain something, we can go with it.
Oh,
About
okay.
the Simulink
Yeah,
blocks.
yeah, let's do that. Yeah, we can try it on a different example for now. We don't need a stop sign.
Okay.
I'm just actually running the manual drive on my end to see if it works.
Okay.
Okay. Yeah, let's do that. So, okay. So what you're getting here, so let's walk through the Simic model, starting with the capture RGBD. So, in here, when you're using the video 3D collection of blocks, you have the video 3D initialize. The video 3D initialize points to, oh, see, okay, I think I know what's going on with your, I think the issue is yeah, the issue you're having with the previous one is because the game controller was not connected properly. That's why,
Okay.
because I'm getting the same error. I don't get that error if it's connected.
Okay. Sorry.
Um, so it's not connected. That's most likely the reason. Um, the error message it gives is not very descriptive. Um, but anyway, we'll go back to that example once you get your gamepad connected, and I'll show you how you can look whether or not the gamepad is being detected or not. Does that sound good?
Yeah, yeah.
Okay,
Actually,
so
the
for now we'll continue with this. So right now, if you double click on the video 3D initialize, so this is set up for a certain device. So then yeah, there's not too much here, but the sample time is set to QC get step size times 30 hertz divided by that, right? So it'll take so in here it'll basically set, I just want to see what rate this will be at. Um so if you look at this and you can maybe stop your model for now, just to don't not to drain the battery too much. Okay, so it's set to run at 30 hertz. That's what that line does, right? So in here, if you take that, copy it, and paste it inside MATLAB, you'll see that it's set to run at 30 hertz. So again, QC gets the step size of your model. The step size of your model, sample rate, is set to 30 hertz. So then because your model is running at 30 hertz, your camera is also set to run at 30 hertz. So that way you're not because the camera only has so much bandwidth, right?
Yeah.
Okay. Yeah, let's go back to Simlink. This I think we covered yesterday. So it's the same thing as the hardware test interface example we did. So you're getting the RGB stream and the depth stream. So we covered that. So if you go back to the main part of your model. Okay, so let's go to the find stop sign location. Okay, so in this case, if you zoom up, the main things you want to do here, so it's the plane, you're getting the raw RGB video. So this is like the raw, the full video in the first video compressed block. Uh, the second video compressed block is showing you basically the blob detected, right? So, and the detection of the blob is dependent on how you adjust your saturation and your value settings, right? As we discussed with that, the HSV values. By the way, I didn't really ask you, but who is familiar with HSV? Is this like really new to you guys, or have you seen it before?
It's new, almost all. It's new.
But do you understand the concept? Like it's similar to RGB, it's just a different color wheel. Kind of, except it's not a wheel, it's a
Regarding the threshold, you mean that we have to set a threshold where we can binarize the image to be white and black?
correct. That's exactly it. Yeah. So what you do is when you run the model, you can hover your mouse over the image and it'll actually tell you like the HSV values of the different point where your cursor is on your image. And then basically what I do is you can move your mouse around to a certain range of your stop sign or your lane, whatever object you're detecting, to kind of know what the minimum saturation and what the minimum value is, right? So you can find the min and max for saturation and value based on just getting the data directly from the image. Once you do that, so if you double click on that block,
The desired HUE, you get it as a 0. What does that mean?
you're not using hue. Because you're detecting red, you don't need the hue. You have to look at the if you go to File Explorer, let's just open up that manual. Yeah, RGB imaging, you can open that, but it won't be in there. But this will show you the guidelines of how to do it. Yeah, so everything I'm doing here is all documented, right? So we're doing the recording, but at the end of the day, this is all very well documented in all the PDF files.
Regarding
Yeah.
the
So
threshold,
okay, yeah, regarding the question, yeah, so like I said, the HSV wheel that I showed you is not in this. So go to File Explorer.
File Explorer, okay.
Windows Explorer, just open up a file. Yeah. Okay, go to Quanser, Documents, Quanser, Concept Reviews. And you want to scroll down to, no, more. Yeah, keep going down. Color spaces, yeah. Yeah, so this was showing you earlier. Yeah, if you go down, there is, so that is your RGB down below there, right? So that is probably what you're more familiar with. So keep going down, and the next one will show you HSV. HSV is just a different color scheme, guys. That's basically what it is, right? So HSV stands for hue saturation value. So it's using like light intensity information, like it says so. And in here is basically showing you, I guess, the HSV color wheel, if you will.
meaning that it is another representation of the image.
I didn't quite get that.
Meaning that how we present the image using the HSP.
Well, that's what we're gonna do. But I want to show you the color wheel so you have an idea, right? So you're asking why the hue is set to 0 is because we're detecting red. You don't need the hue to detect red.
Okay.
So over here we have angle which defines the color, and then we have the height which defines the brightness or darkness, correct?
Yeah, exactly. Yeah. Yeah. Yeah, that's well put, actually. So your saturation is just your color, and then your value is the brightness. And what you'll find is, if you turn off the lights, then you need to adjust your V. But if you turn them on, then you need to, you need to adjust it depending on the lighting of your environment.
Correct.
Yeah. Yeah, that's a good way to explain it.
The stop signs are also ready. It's
Okay, let's give it a shot, guys. Yeah, let's run your model again.
fine.
So you don't need to go monitor and tune, actually. I mean, you could do it, but you could also go to deploy.
Deploy. Correct.
Just to give you, because we didn't change anything, right? So you can go deploy, connect,
And
and
start.
then start. This shows you like step by step what everything does.
Okay. Fine.
Okay, so great. So you're getting your depth measurement and your raw feed and all that. So inside your raw feed, we don't see the stop sign here.
It stops. It's ready. Can you please put the stop sign in front of camera? Or you can rotate the rotation.
You change the class?
Yeah, whatever is feasible for you. Great. Yeah. Yes. Fine. Correct.
Oh, actually, you're getting. Okay, that's so as you can see, you're already almost there, but so if you take your mouse cursor over the raw RGB image and you go to the red portion of your stop sign, so go to the red, then you'll see that on the top you get numeric values at the kind of the
Yeah. On the okay.
on the menu, I guess, or the top bar of that
Yeah.
that window. So the last two digits are your HSV values.
Okay. Fine. HSV. RGB, HSV. Fine.
Yeah. Yeah, so in here, you can see that your saturation is like 255 and your value is like 176. But if you move your cursor from left to right, again, stay in the red region, you'll see that
Yeah.
that might change a bit. So that'll give you kind of a range. So you can see your saturation is pretty high and your
Yeah.
value is also above. That's pretty consistent, right? So you're pretty much always above 225 and at least 170, or 150 for the value. So now if you look at your settings for your RGBD, now find stop sign location.
Yeah. Yeah.
So you could adjust your minimum. Yeah, I think your maximum is okay because it's 255 each. That's fine. But based on your image here, you may want to try just to adjust your. So the best thing here, guys, is basically try to adjust your window so that you can see both of them together. I know you have multiple monitors, so you can probably do that, but
Yeah, we can resize it a bit.
yeah, exactly. Do that and then just adjust it on the fly.
Uh,
So for that, you might want to set it to 200, I think, saturation. Try that. See if it makes a difference. It might make it worse. It might make it better, right? Because you never want your range to be too small.
Okay, so should we put the maximum as 200?
No, there's no maximum. It's just, your minimum is set pretty low and your
Oh,
both values are quite high,
okay.
right? Like
Yeah.
this is the
Okay,
minimum.
got it. Okay, so
This is the
this is
minimum
the minimum for
saturation.
both. Okay, it's minimum for both. Right?
Yeah, click on apply.
So
Okay,
now
so that's too much. Just change one at a time.
Okay.
Yeah, click on apply.
Oh,
Oh, that's pretty good. Yeah, that's quite good.
What you, okay, you need camera. Wait, wait.
Oh, the problem, try it now, try it now. Just okay. No. It's too bright. See, it has to be done.
Oh, okay.
Turn the background, it's going to be red.
What's your?
The red background is fun.
That's all.
Okay, thank you. I just scroll down. So it's great.
بس كنت بشوف يعني بتكحت اي احمر بس.
So that's pretty good. Now, yeah, that's really good, guys. So if you go back to the main part of your diagram, then yeah, there's the distance to your stop sign, the blob, right?
Okay. It is actually not 3 point, it's less than a meter. And actually,
Okay, so in that case, then go to find stop sign distance. No, that's not it. No, sorry, that's not it. That would be. I'll have to confirm that. I'm not too sure why that is.
okay, fine.
Yeah, let me look into that offline. I'll try it on my own. I'm not too sure. Try to maybe stop your model and restart it, maybe. I don't think that'll make a difference, but
Still the same value.
yeah, I got it. Yeah, I can read. Okay. Yeah, it's not. I mean, I know where the issue is. It's definitely in the find stop sign. It's not quite accurate, right? Because your find stop sign location detects the value in pixels. So that is probably correct because you're detecting the image very well. You've adjusted your HSV values correctly. But in the find stop sign distance,
Actually, they are trying with some red screen and the mobile you can see now it's working pretty accurately. It's distance you can see now.
Some lighting. That's it.
I see.
When we use mobile phone, it's
When red color
Oh,
is
I
used,
see. Okay, that's interesting.
you can see now it's almost very much accurate.
Well, yeah, the
Now,
one you had before. It seems like the white is maybe,
just make it sharp red, just red.
yeah, make it sharp. Okay, so maybe there's no, I think the settings in the model are okay. Maybe we need to just. Yeah, because that's,
Now you can see. Now it's accurate. Almost half meter is the real distance as well.
so is that distance correct now?
Yeah, it's correct.
Okay. Okay, so maybe it's a matter of us adjusting the HSV values more correctly. So let's go back to the stop sign
Okay.
and yeah, double click on that. And try to reset it back to 100 for the first value for a minimum saturation of 100. Yeah, click on, okay, that's, okay, go back and let's try to adjust HSV values. So go back to 200. And let's try adjusting the other one now. Maybe increasing the other one to 150 maybe.
Same.
Okay, let's try increasing it. The minimum to 175.
Okay, so I think now it's more noisy.
Yeah, it is more noisy. But it's okay. Yeah, that's not, yeah, that didn't help. Okay, so go back to,
It's 50.
yeah, and let's increase your saturation minimum.
Yeah. Then
Go to 225 for the minimum.
this one.
No, the first one.
Okay, we keep
Yeah,
it
100 and 225 for the first one for saturation.
Seems still be the same. Think the
No, you can't go
maximum-
more than that. That's already maximum. So,
Okay.
okay, go back to the raw RGB and hover your mouse over the stop sign. Let's see. So saturation doesn't fall below 250 to 245.
Yeah.
And your value is above 150
Yeah.
at least.
160.
Try moving a stop sign more to the center of the Q car.
Okay, fine.
Like physically, move the stop sign
yeah.
right in the middle of the lane. Yeah.
Yeah, he's putting it in the center. Correct.
Oh, that's why. Okay. So, see, there's a little red tag behind the stop sign. I wonder if it was detecting that instead.
It's quite accurate. The distance is accurate.
See, now it's probably detecting it without any issues. So I think it was past the field of view actually, because the RGBD camera has a certain range, like a horizontal field of vision. Maybe because it was off to the side, it wasn't detecting it as well. Because if it's too far off the side, then that might be problematic. I think that's maybe my best guess. Second one is maybe it was interfering with something else. some other color there that was red, but the only thing I see is there is a red sticker on the road map there in the bottom and the right,
Yeah,
but still that's
Yeah,
pretty
yeah.
small, so I don't think it would be.
Yeah.
Yeah. No, I mean, yeah. But now it's detecting well, so that's. So just make sure it's within that horizontal field of view, and you should be okay.
Fine.
Okay. Okay, great. I think we're done with that. So you can click on stop. Okay, do you have your joystick connected now?
Yeah, it's connected.
Okay, so let's go back to your manual drive, and yeah, double click on that. Hold on, hang on. Go to gamepad, the first block. Click on game controller. Let's make sure it's being detected now. Okay, click on the controller number. Up above. Okay, should be 1. Okay. Click on OK. Okay, let's click on monitor and tune. It doesn't look like it's been detected. Because you should see that controller number under game controller. It should be 1 and the name of the controller usually.
So
It's like Bluetooth USB dongle, right?
yeah. I think we can check it in the settings, USB devices.
Yeah, definitely you can check it. Yeah. Yeah, we need to make sure we see it there first.
Add device, probably we have to add it first. USB, optical mouse. Probably it's detected as, no, it's already connected.
No. Okay, there's a button there, like a mode button. Maybe that's not on properly. Yeah, there's an LED light next to the
Yeah.
mode button.
Here.
It should be off.
The LED should be off.
Yeah, if the LED is on, then press the mode button again to toggle it off.
Okay, now it's off.
Okay, and now try replugging your dongle in it. Oh, wait a minute. There. I think I found it now.
Yeah.
Okay, now let's go back to your gamepad, your manual drive.
Yeah.
Now double click on game controller. Okay, click on control number. Okay, select 1. That should be okay. Cancel. Okay, click on monitor and tune again. Okay, try closing your model.
Sorry.
Close the Simic model.
Okay.
Okay, open up manual drive again. Yeah, go to gamepad. Just want to double check the controller number. Okay, now keep it on 1. Okay, click on OK. All right, let's try it again.
It says the file could not be found. Quark.
Yeah, I know what it says, but it doesn't.
Just the model setting, the IP addresses.
Oh, wait a minute. Wait a minute. Your dongle has to be connected to your Q car.
You
That's why.
Okay, so it's connected
Yeah,
to
yeah,
the
yeah.
PC. Okay, fine. Yeah, to grab it to the car. Yeah, now it's connected.
All right. All right. Now click on game controller. Okay, controller number.
Yes.
Okay. Okay, select one. Okay, I guess that's okay. Okay, let's click on OK. And let's do a clean. And okay, let's go to click on monitor and tune now.
No. Now.
All right. My bad.
No. Now I think it's connected via some LEDs. Yeah.
All right. It shows you the commands here. I guess you can use that as your base, right? So your left button, LB, I think it's labeled LB, right?
Yeah.
You want to press that to arm it. And then your left stick can be used for steering, and your right throttle, the RT button, that's your throttle. So the right button.
So. It's not working.
You need to make sure you keep pressing the LB on, right?
Okay.
The LT needs to be like pressed to arm it.
Okay, so we have pressed it. Yeah.
Now try pressing RT.
RT, right? No, nothing.
Try clicking on mode again.
Okay.
Is the LED on?
Yeah, the LED is on and the joystick.
Okay. So click on mode to turn the LED off. Now there's a switch as well on the gamepad. That might be the issue.
Yeah,
It's hard. This is the issue with doing online. I can't see the joystick. Can you show the joystick on the camera just for a minute? There should be a switch there. No, if you just rotate. Yeah, that switch there.
Yeah, here.
Okay, now try LT. Try to arm it LT and put a throttle RT. Is it moving?
No. We should. No.
Okay, wait a minute. Okay, the switch in the back of your F70 should be in the X position.
X, yeah, it's an X position.
It's on X.
Yeah. Now it's in next.
I think the stop sign is.
And the LED you said was off, right? The LED next to the mode button is
Yeah,
off.
it's off.
So press and hold the L button.
LB, right? LB.
LB, yeah. Okay, hold
Okay.
it and then
Fine.
try varying your left stick.
No, nothing.
The right throttle, the RT button.
Yeah. Nothing.
Is there range? Is there any range?
Okay. Yes, sir. Maybe it's not a good one.
I mean, I don't.
This is for the connection and the.
How many minutes connected to what they are? Okay, so.
It's about communication, not about no, about the.
There will be no this is connected to the.
That is not. I don't know about the robot. I don't know. Because on the computer we can see it from the computer, but on the robot we can't see anything.
We can use.
Try toggling the switch.
Let me check. It did put it.
Try toggling the back switch again. Maybe going back. It should be in the X, but
Yeah, now it's an X. This one. It's what I'm doing. Sure.
And the back one. I have a that's it. USB.
okay. Make sure it's on. Okay, so you're on X. There's no LED. Okay, let's stop
Yeah.
the model.
Okay.
Let's stop the model. Now let's go to the Q car, unplug the dongle and replug it in the USB.
Like the USB. No, yeah, there. Pull the car. No problem. Pull the car towards you. So replug it. Plug it. Yeah, no, yeah, in the same place, no problem. Fine. So we plug it again. No, okay, fine.
All right, let's try again. Is it connected to USB 3 port? Make sure it's USB 3, not USB 2.
Oh, now it's working.
Oh, did you change your USB port?
No, same USB port. So now it's working.
Okay.
Yeah.
Could you do me a favor and double click on game controller? I just want to see something.
Sure.
Okay, never mind. Okay, it's still one. Okay, cancel. Okay, good.
So we have to press it, then we can slowly.
You have to continuously press the.
Yeah. If you leave this button unpressed, then it won't. Okay, so if you people want to try, whenever this one is the button, it should be pressed always, and then this is the throttle button, and this is the steering wheel. Do not push the throttle fully. Okay. So yeah. A little bit. This is steering. Be careful, like, slowly, the throttle should be just accelerator.
Right, I think that's a topic.
We don't, we just unplug the USB dongle and we plug it, so it's like. I just passed to another student.
You guys are pretty good at this.
Yeah,
Jesus, that's amazing.
You play a lot of games on your computer, right?
Who's driving this? This is like, I've never seen anybody drive it that well.
multiple students are driving it.
Do you guys play a lot of video games or something? Like, anyways,
Yeah,
well, I'm very impressed.
thank you.
You don't even need a self-driving car. All right. So as you can see here, it's using, so the game controller is like the low-level access to the outputs to all the buttons and sliders and whatever else you're using the sticks, right?
Just press it.
And then that gets mapped into a steering command and throttle command, whether you want to go forward and backwards. So if you go back to the main part of your CIMIC model, that mapping, the interpretation, as they call it, is done in the second block, right? So
Yeah.
so using the percentage inputs from your joystick, it calculates what the motor command is and what the steering command is in radians, like an angle measurement, not just a percentage value based on the raw input from the joystick. You can also see the arm button, right? So the arm button is going 0 when it's off and 1 when you are pressing the button.
Yeah.
Then you have your indicators and lamps, right? So the indicator and lamps will send commands to the different LEDs and headlights that you have based on those commands, based on your steering and your throttle. That all gets interfaced inside your basic QCar IO model that you're familiar with now.
Yeah. You have to be careful, not too hard too fast.
I'm a customer. Oh,
Okay.
It's okay. Okay, so it's enough. Okay, fine.
So I kind of give you a general overview of the model here. Are there any other questions about how this is done?
I think it's okay for no more question from your side.
Okay. Okay, if you're done with this, then we can click on the stop button and click on close. And let's go to lane following.
Okay, so example 1, right?
Yeah. So in this example, now that you've done manual drive and you did the RGB imaging, so now you kind of have to redo what you did with the stop sign by adjusting those HSV values, or in your case, just S and V, but you're doing it for the lane.
Fine. So first we configure the IP address. Okay. And then we go to the
Go to the color thresholding, HSV, yeah, you got it, yeah. So now you might need to just more things because you're detecting the yellow on the lane, so you might need to adjust the hue as well. But we won't know until we see the image.
First, we have to see the image, correct? So for that, we should run another example probably for this one.
Yeah, you can run. You can do that. You can do HSV selection, or you can run the full example. Just don't drive the car, because right
Okay.
now it's disarmed.
Fine.
So if you look at down in the left-hand corner,
Yeah, here.
the Q
It's,
car stop. Yeah, so right now it's disarmed, right? It's 0. So as long as that's kept at 0, you can adjust it, but it's up to you. If you want to go to the HSV selection, that might be easier.
Okay, so we go to this one.
Okay. Okay, so in this time we're gonna need to do some adjustments. So yeah, you got it. So I'll let you take a look at that.
Which is minimum is the,
Yeah, your hue is quite low.
yeah, it's 20, I think minimum could be 20. Thinking to 20 the minimum. And this is actually the minimum. I think 100 would be fine for this. Let us check over here, so we may have. No, it's too far. 45, yeah. I think we should check a bit away, not too much close, so far may have a little bit large like 50. I think let's start with 50, yeah, 50 and
Guys, I'll be back in like give me 45 seconds or a minute. I just need to do one thing.
okay, fine.
Just keep doing this. You're doing well.
Okay, fine. Here should be. Right. So here is our basic. We have so we have something. Okay, so here is the HSV selection, right?
Yeah, but we have to select V as well.
E. But, I think 90. No. Keep it 150. The 150. So 150 is minimum, right? No. It's too actually far. And we won't be interested in that. 150 minimum situation is how much? Saturation is 50. 50. Now we can see what we are doing. 20, right? Okay, I think we should get a plan. Okay, so we have no plan. But so what we can do, that the maximum is not the problem. We never touch that, but we can suppose like just like this. There was actually no need to make it as well. The minimum.
All right. How are we doing here?
So we are like this. And minimum value we change. Okay. So we have to just bring the lane in the screen, right? Not the side objects.
Did you guys look at your? Because you're kind of tuning this on the fly right now, right?
Yeah.
Because before you were looking at the, like, what are your ranges when you look at your image, right?
Yeah.
Could you go back? Just for my own purpose.
Yeah.
Now, if you go back to your image feed and hover over the yellow line,
Okay, fine.
so your hue is below 50. Your saturation is averaging around 115. And your value is quite high. It's above, like, I'd
Yeah.
say, minimum is 150.
150.
You don't want the ranges to be too small sometimes, right? So I think, so right now your value, your maximum value is set to 178, which is way too low.
Oh, yeah.
It's 178, you're measuring 200 and stuff. So set your maximum value to 255. Just
Correct.
crank it up. There, that's better.
Yeah, something very fine. Yeah.
Okay, and then your minimum value, I would set at 1 or 200 maybe.
Okay. No, it's
Okay, that's
not
too low,
good.
so 150.
I think we can change it here as well.
Okay, that's good. Yeah, okay.
150 probably. Yeah.
Okay, then your hue was low, right?
Yeah.
So set that to 0. Your minimum hue should be 0.
Okay.
And try to decrease your maximum hue. Okay, so actually it was better when your hue was
20.
20.
Yeah, like this.
Okay, go more. I will go maybe 25.
Okay.
Yeah, not too. Okay, that's too much. Yeah.
23,
Yeah,
suppose.
well, guys, I mean, just 20 there. It's not 20 is fine.
20.
Yeah, let's go.
Okay, fine. Okay. Fine.
Yeah. Okay, and that's pretty good so far. Let's look at your saturation.
Okay. Minimum, right.
I forget what the.
You can check it again.
Yeah, go back to your image.
The most of 100 about.
Okay, I would just decrease the max, I think, for the saturation, but I would keep the minimum as is. I think 20 is fine. But I think their
Okay.
saturation doesn't go up to 255, but that probably won't matter too much. Your image is pretty good as is.
Okay. So
No, you don't want too low.
I think we should increase the minimum a bit.
Sure, try it out.
We leave it.
Yeah, keep it like that. That's fine. Mm, okay, that's not bad.
Okay, fine.
You can always fine tune it more, right, on your own time. We have
Correct.
but that's quite good. Okay, let's go back to your main portion of your CIMIC model.
Okay.
Okay,
Yeah,
all
here.
right. Yeah, you're gonna want to stop your other Simic model now. So if you're happy with these values, you just need to basically use those values in this model.
Yeah, so what are the values? 20. 20? Yeah. 20, then 23. 23. 150. Then 150. 150. 50. Maximum. 250. Oh, yeah, 74. Huh?
40.
This is 40. Okay. Fine. So it's okay. So we change the values.
Excellent. Okay, let's go back to the main portion of your model.
Yeah.
And yeah, you guys can run it.
Okay, so we have some screens over here.
Okay. Okay, good. That's looking all right. So it's displaying the tracking diagnostics there. Okay. If you guys are ready, then you can arm it.
Okay. Let me minimize it a bit so we can see the screens.
Yeah. Sounds good.
We have to go for the home button and we also have to see the screen here.
Yeah.
Okay. Okay, fine. So we are ready. Should we arm it?
Yeah, arm it.
Okay. Now it's moving.
Oh yeah, nice.
Everybody can just get blur it too much. So the line is ending and it's almost out of the road.
Yeah, when it line end, then it'll stop, right?
Yeah, we stopped it. I don't know whether it will stop automatically or not.
Oh, you stopped it.
Yeah, we disarmed it because we have the obstacle then.
Did it detect an obstacle?
No, actually there was an obstacle. It was going, okay, let's rearm it. So it's going. Yeah. So it touched the wall and also forcing the wall. We have a small wall, so we have to disarm it.
Yeah, it should stop when it detects an object.
No, it did not stop. Let us try again. So we are following the line. So it's going straight.
Oh, see now it detects it again. It's
Yeah.
good.
The line is followed very accurately.
I mean, this is a very it's kind of like the simplest lane tracking example, right? Like it does have a lot of stuff built in. For example, it does detect for obstacles and it should stop. But at the lane at the end, let's see what it does here.
So,
It does keep driving, right? So then
yeah, we have to disarm it. What it's doing just
Okay.
No problem, just stay. It doesn't stop, and yeah, lane is followed perfectly.
The lane is very good. Yeah, I gotta say that's one of the. Well, your lab is well set up and everything, and you did your HSV selection as well. So, but that's the main thing this does. It like the obstacle detection would require more tuning and stuff, but that's not like this is working pretty much as I usually see it. The obstacle detection is it's kind of it's fairly simple. I think it depends on the color of the object, but I mean, this is just a starting point for lane following, right? And you can refine this example. We also have autonomous driving car example 2 that you can look at on your own time.
Yeah, sure.
There is an question. So, which algorithm is using to follow the line?
Which algorithm? If you look at the automated driving here, yeah, the blue block, the first blue block, yeah. So this is in adaptive cruise control. This is how it's doing the checking the nominal speed based on your steering command.
يعني the input to this module is the obstacle distance and the minimal speed and steering. Three inputs.
Yeah, well, okay. I mean, your steering command is given from, if you go back to the main portion, like we don't have a particular name for this algorithm because it's done, okay, you're doing your color thresholding and you're getting the blob detection, right? So then based on your binary image, you're getting the lane location. So you're finding the centroid location of that lane in order to get the position of the lane. That is giving you the steering command
Okay.
based on the error, right? So the lane location, could you zoom up, please?
Yeah. Lane location.
The
Okay.
lane location here, right? So this is what is detecting the fine objects gets the centroid position of that, and then it gets the location of the lane. And then you can get the error of the lane, right? Because you have the
The
you
error
want
between the vehicle and
between the
the
car
line.
and the lane, right? So that's your error. That gets, so if you go back to the main part of your model, then that gets to your steering. So you're converting. So you're converting that into a steering angle using that gain. That's your steering command. Your steering command goes to the obstacle detection. So obstacle detection.
Yeah.
So there, in your steering, it'll take the image depth and the steering command. So if it detects an object, depending on the object, of course, then it might you know it might stop the car. But here it calculates the distance of the object, right? But this is basically obstacle detection, so we can skip that. Go back to the speed controller. So the automated driving before, yeah, that's the controller. That's the actual EID and the feed forward controller. So based on your desired speed and the measured speed of your car, so you know the measured speed from the car because you're measuring, you have an encoder on the car, right? The encoder, and you know the radius of the wheel, so you can calculate the linear speed of the wheel. That's actually one of the exercises in this, in the skill activities. So based on your desired speed and your measured speed, you do the old PI controller. You can add feed forward as well to improve it, as we were doing here. And whether or not the system is armed, then it will send the throttle command. So this is doing the throttle speed control, and that gets combined with the steering command that is done with the lane following that we saw previously. So that's basically how the algorithm is, right? There's not a particular name for this, but it's using, the speed controller is using your standard PI controller with the feed forward action to improve the performance. And it's just using the inherent blocks from Symlink for the find objects, detecting the centroid of the blob of the lane, and then it computes the error between the lane and the Q car, converts that into a steering command. So that steering command is used with the desired speed that you set. Desired speed is like 0.2 meters per second or something. And the speed controller does the throttle speed. So the throttle based with the lane following steering command, they're combined together, and that gets commanded to the Q car.
Okay.
Does that help or?
Yes, clear.
Okay, good. All right, excellent.
Okay.
Are there any other questions about this model?
No questions so far.
Okay. Well, I mean, again, you guys can. We're kind of overviewing everything. I'm trying to give you more detail than usual because you guys are pretty advanced. But if you have any questions, make sure you can look at these, run in, and if you have any questions, then we can address those in the follow-up sessions or via email, right? So I'm always available for making sure that you understand all the material that we have in order for you to meet your goals when you want to modify these for your own purpose. Okay, if you're happy with that, we can stop that model.
Sure. Thank you. Stop. Yeah.
All right. Okay, so the last application that we didn't run was the
Point
point
cloud.
cloud generation. Yeah, let's try to run that really quick.
Okay, so fine. Okay.
Oh, see, that's updating fast now.
Yeah, it's updating fast. Now it's quite good.
Oh, this is great. Okay, this is good. So it's probably something that was not configured right in the other Symlink model, probably the update rate of the polar plot. Because if in here, in this polar plot, if you look at the menu for the polar plot, there's a properties icon.
Properties icon.
Yeah, that one. Yeah.
Okay.
Oh, no, the next one, not inspector, the next one. Yeah. So make sure the update rate samples is set to 1, like what is done here. I think in the other one, the theta direction was actually clockwise. When it should be counterclockwise, and the update rate might have been higher than 1.
Yeah,
So make sure it's the same settings as this, because these are the correct settings. This works.
okay.
Oh yeah, this is working great now. Okay, click on cancel.
So, right.
So the body frame, this polar plot is basically exactly like we did yesterday in the hardware test, where it's just capturing the raw distance and headings from the LiDAR, and based on the cue card position, it's giving you those objects, the text, right? So all the rule maps, it'll get the distance and the heading, and it just puts those with respect to its body frame. Now the other thing it does is if you go back to your CIMIC model and double click on the video compressed display, you should be able to find that, yeah, in there. You might need to write, no, not scope, the last one, video compressed display.
Okay, so I'm. Yeah,
It's already open. It's maybe moved to another screen. Try to click right on it.
okay,
Go
so,
back, click right, and try to maximize it.
okay, sorry, let us minimize this one.
Yeah,
This
we might need to re-add the block. I actually had to
yeah,
kill a mice.
yes. Yeah,
Oh,
yeah.
great.
That was it.
Okay. So this is showing you the XY map instead,
Yeah.
right? So the point
Yeah.
cloud is taking the distance and headings and is populating an XY map. So that's
Okay.
Cartesian. So if you look at the point cloud measurement, the point cloud block,
Okay,
so based on the distance and headings that are outputted from your LiDAR, it finds a contour. So it finds those values in pixels, and then it creates the point cloud map, right? And then you basically have a 400 by 400 map that it outputs to that video compressed display block.
yeah,
You can adjust the maximum distance of the objects. Right now it's set to 4 meters, but you can bring it down or increase it.
okay. So we increase it to suppose 8 meter. Let's see.
I don't think, yeah, because your road panels are probably covering everything else, so.
Yeah. Let's go. Look at
But I think your LiDAR can go up to like 20 or 22 meters.
Yeah. Think we have to about it and we'll go. So we have error over here.
Maybe try, did you
Too
try?
much.
Yeah, too much, yeah.
Okay, first make it. So what was the default one? We keep it 4, we rerun it, and after that we have. Okay, so we.
Try to bring it down to like 1 meter.
Okay, fine. 1 meter.
So you do that. I just want to see if it'll.
Yeah.
Right, so now you can't detect any of your row panels because it's too short.
Yeah. Check it with 5 meter. Okay, so I
Yeah,
think we.
4 is the max, guys.
4 is the max, yeah, yeah.
Because that's how those fine XY contours is defined.
Yeah. Whatever is in the 4 meter range. Yeah. 4 meter from this, from the LiDAR center.
And you can double click on the contour to point cloud, for example. The first block
Okay.
just finds the XY coordinates for that, but then based on your image size, if you want an image size of 400,
Mm.
then it calculates based on the pixels, it gets the XY coordinates for that.
Okay.
All right. I guess we could take a look at the first block as well, just to show you how it gets the XY positions. Find XY contour. Yeah, find XY contour. You'll just see here that the X and Y are, this is basically just, you have the heading and the distances, and it's just using, sine and cosine, it's just trigonometry. So no big surprises there. Okay. So this is basically kind of a segue into doing more advanced stuff. For example, if you want to do localization and stuff like that, then this would be kind of one part of that, right? A small part of using the LiDAR to get the XY data, and then you combine that with other sensors, with encoder and other stuff in order to get a better position of your Q car. So, but it depends, right? We have also like I guess a Hector Slam base that we have actually in Ross, like that just uses the LiDAR sensor by itself. That's actually the main example we have in Ross for the Q car. But there's other SLAM examples that will use their more sensor fusion. So it'll use the autonometric data of the Q car, the encoder coupled with the LiDAR.
Correct.
But you guys know that more than me, so. Any questions about this, guys? Any questions?
No question, no questions.
Okay. I guess we can stop this model then.
Fine.
Okay. Well, that's great. Okay, so we've covered all the CIMIC model applications for the
Yeah.
Q car, went through all the hardware tests. Your LiDAR is working fine based on this example, so it's probably something with the configuration of the other hardware example. We can have a look at that, but we've concluded the CIMIC portion of this. So the next phase is to branch off to Python. So I was hoping to get the Python in this session, but right now I believe it's 4:20 p.m. your time. So I'm wondering if there's anybody available to make sure that Python is probably set up on your end in order for us to make sure we can get started with running the scripts tomorrow, or how are you guys feeling? What is your I don't know if you have any classes or what your schedule is like.
So we have Python. Can we proceed? We have classes right now. Okay. So the students who are here, they have classes actually now.
The students have class.
Yeah.
Okay, that's fine, because I mean, I think we've done most of the training that I definitely want to get through. We finalized that, so that's good. Tomorrow, we're basically redoing the hardware tests and the applications, but all in Python. But I just want to make sure if any of you guys are available to hang on the line for maybe like another 10-15 minutes with me,
Sure.
then
Sure.
okay, that'd be great, because that way I just want to make sure Python is properly configured on the ground control PC and on the Q car.
Fine, fine.
You're more than halfway there. I just want to like confirm that. But that's it. I mean, for all the students that joined us today, thank you so much. I know you have a class, so have a good class, and we'll see you here tomorrow, and we'll resume on the Python. And for the rest of the people, yeah, if I can borrow your time for 10-15 minutes, we'll just make sure that we can run, we can configure Python properly.
Sure, sure. Once again, inshallah, we will meet tomorrow, inshallah.
All right, excellent. Okay, let me okay, so yesterday we ran the batch file, right? We ran that batch file to copy all the resources on the ground control PC. Now, we did get an error because it had an issue copying the QVL folder.
Yeah.
So I want to make sure that that got copied, right? So let's see if the library got copied to your local drive. So if you go to, yeah, go there and go back to Quanser,
Mhm.
go to libraries.
Mhm.
Hang on 1 minute. Yeah, libraries, go to Py. Oh yeah, you're. Okay, you're definitely missing one. Go to Python.
Okay.
Okay, you're missing QVL. Okay, go back to libraries and go to resources. Okay. I wouldn't mind trying to run the setup batch file again. The thing is, guys, when we run the setup file, it'll overwrite all the Simic models that we went through.
I think that's not a problem because we have just to change the IP address in all the model and we have the HSV setting. That's fine, I think.
If you want to save, but I mean, for the applications, if you want to save those as your personal folder, we can do that. So if you want to save like a backup.
Sure. So we will save.
Yeah, go to examples.
Sorry, examples and application. QCar,
SDCS.
LTCS, UCar.
Yeah, QCar. I think the hardware test doesn't really matter, but that you can yeah, back up and just move it outside that folder.
Okay, so
And just copy it somewhere else.
okay, so we place it on this desktop.
Sure. Okay. Okay, go back to your downloads folder and let's try running the setup script.
Okay.
Let's try this, right? So go.
Sorry, where?
Where's your research studio? Like the earliest one.
This one, right?
Is this the one we got yesterday?
Yeah,
Yes.
this is.
Could you maybe open up a command window?
Okay.
And type setup. Okay, right now, is there any firewall setting on your PC?
I think it's connected with your STC Wi-Fi, right? Ethernet. Yeah, it's actually university internet, so probably some firewalls should be there.
That's probably why.
Yeah.
Because we've seen that issue a couple of times, and it's usually either a firewall locally, but this is a ground control PC that was pre-configured, so it's most likely the firewall of the university interfering or something. But let's try running it again. So just
Okay.
type setup. No, go to your PowerShell.
Okay,
No.
over here. Setup. Okay. And this is,
Yes.
yes, okay. We connect this PC to the your Wi-Fi. I think we have to connect it to the mobile network. You should come.
Okay, let's see if this will work. Yeah. Yeah, keep. Yes.
Okay, so there it is. This requires a valid internet.
We'll do it manually. You can't get it. We've seen this there before, like I just, yeah, yes.
Okay.
Access is denied. Yeah.
So should I proceed? Press any key to continue.
Yeah, hang on, I want to take a screen capture of this.
Okay.
C drive user add data. Okay, yeah, click on OK. Yeah, press any key.
This is. Yeah, fine. So we also have a Wi-Fi in outside network. Should we connect to that? We can try that as well.
Up to you if you want to give that a shot.
Yeah. So we are just connecting and we can remove the Ethernet cable. Yeah, it's connected. We'll remove the Ethernet cable. We try it again.
Okay,
It's remote. Please let me.
but is it probably going through the same firewall, right?
No, actually now it's outside network, not university.
I see.
Means that mobile network. Yeah. Yes. Yeah, still have it.
Okay. Click on yes. Yeah, it's something local.
Yeah.
Yeah, that's the thing here. Okay, press any key. All right. Okay, so okay, we'll do it manually then.
Okay.
Let me show you basically what you can do here is I'll just share my screen. Well, no, actually no, that's okay. No, I don't need to share my screen. Yeah, go to Chrome or Edge, whatever you want.
Fine.
And just type Quanser GitHub.
So, GitHub. This one, right?
Yeah. Okay, go to Quanser Interactive Lab Resources. Then you see the green code button. Click on the down arrow and click on download zip.
You will go to speed, internet speed.
Okay, wait for that to download.
Yeah.
All right, so go to your downloads folder.
Okay. Yes.
Yeah, extract.
Okay.
Okay, so yeah, open up that. Yeah, open up that. All right, so then you'll have all the libraries in here. Yeah, double click.
Yeah.
All right, so you can see there's two folders here. So we're gonna need this and then open up the second Windows Explorer window so that we can see what you have in
Sorry.
your Quanser folder.
Sure. Side by side, okay. So we need to go to Quanser folder and then to
Libraries.
libraries and yeah.
Okay, go yeah, resources.
Okay.
So your resources should have so you can copy RT models from the left and paste it in here.
Done.
Okay, I'm just double. Okay, that completes that. Go to Python. Okay, so you have HAL and you have PAL, but you don't have QVL. So copy and paste QVL. Okay, go back to libraries.
Okay.
Uh, okay, give me 1 minute. Okay, hang on, I think. You're just missing one library. I'm not sure if you're gonna need it. We covered most of them already. Okay. Okay, let's try this then. Yeah, actually, no, you're gonna need one more. I think I have to send it to you. I can't send files through here though. Yeah, if you go to your Quanser library, under libraries, there should be a general folder. And you don't have that, so because it should be Python, should be general, Python, and resources, and you're missing general.
Yeah.
I'm just gonna send you my version. Well, it's the SCCS version. It's not nothing. It's the release version of that library.
Okay.
Who could I send this to?
Rahim, are you okay? I
Um,
think Mr. Rahim is with me. You can send.
I have Professor Wadodo here as well.
No, he is actually not present. Me and Rahim, Mr. Rahim, we are Quanser and Rahim.
So who's speaking right now?
Quanser,
Pardon?
Quanser.
I don't know if I have your email address.
Yeah, I
Okay.
do not have yet. Mr. Rahim, please tell you.
Mitch, can you send to my email?
Yeah, I'll send it right now.
नहीं कर सकता मैं शेयर कर सकता हूँ इसमें और तरीके से मुझे अपने बंद कर लेंगे शकील कर लेंगे मतलब इसमें कौन कर लेंगे.
All right. Okay, Rahim, I sent it to you here. Okay, once you get that copied over, we should be done with that part. And then we can copy that to your Q car and make sure we configure your Q car correctly.
You received? You please log in over here on the PC. You download it. So folders. I can for zip file here to you may send and Bluetooth as well. zip file है कि नहीं तो यूट्यूब पे भेज देना पड़ा है? हाँ। Okay, मैं लॉगिन करता हूँ।
Okay, in the meantime, let me show you how we're gonna copy these files over, right? So this is you guys are probably used to this already, but you should have the Windows SCP application on your drive. So let's try launching that. So you type Win SCP.
Okay. NSCP, yeah. On your site.
Yeah, there you go.
Okay.
Okay, great. So your host name, you can enter the IP address of your host, the Q, which is the
Okay.
QCar.
We have the files over here. You can generate info. So we have, I think. Where is zip? Yeah, we have zip. It's downloading. So we Okay, so we have the file as well as zip file.
Okay, okay, let's put down your local drive first.
So, we have to lift it, and yeah,
Yeah, just close this for now.
this one, should I close it?
Yeah, doesn't matter. We're gonna get to it right after this. So.
Okay, so we come over here, right?
Okay,
Okay,
yeah.
fine.
Unzip that. No. You
Oh.
need to unzip the general folder.
Yeah. Think we have some like. Okay, so it's unzipped in the libraries, Quanser libraries. Alarms or
You need to
Python.
Okay, yeah. So now you can delete the zip. You don't need that.
Okay, we can. Fine,
Or just move it somewhere else.
yeah, fine, move to this.
Move it to your desktop PC.
Yeah,
So keep it
yeah,
handy.
Yeah,
Okay, double click on general. I just want to make sure that you have the right RT models.
I think I have to go once.
Oh, yeah, move it back to libraries.
Yeah, we have products.
Yeah, there. Double click on general.
So we are inside general, then we have
Yeah,
products.
Car, yeah. Yeah, double click.
This capture scan.
Go inside. Yeah, it's slow. Okay. Perfect. Okay. Now we should be all set. So let's transfer the Quanser folder to your QCar. So now you can go to Win SCP.
Yeah. To put the IP address here.
Yeah.
Then the port number probably 7001.
No, keep that. No.
Okay. 20. Okay.
Username NVIDIA.
NVIDIA.
Yeah, and your password will be the same thing, NVIDIA.
Fine.
All right,
Okay.
log in.
Login. Yes.
Yeah. Yes.
Okay.
All right, now let's see what you got here. Go to documents. Okay, so then copy the Quanser folder to documents.
Okay. So copy. Paste. Correct.
Yeah, it's kind of a weird way to do it, but that should be okay.
Next week we will come. Mitch, we also have the signal, traffic signals. So.
Oh yeah, the traffic
I
lights.
think
Yeah.
Traffic lights. We haven't tested those in the iOS as far as I remember.
The traffic lights you could probably test on your own time. It's pretty easy.
Okay.
Let me show you where
Fine.
that documentation is.
Okay.
So if you go to your Quanser folder.
Okay.
Yeah, examples. Examples?
Yeah.
SCCS?
Yeah. Traffic light, probably.
Yeah.
Okay. Fine. We will test. But it's
Yeah,
Python, I think.
you can try that out, but we might have time tomorrow to go through it. If not, we can always have another short session, but we would need to schedule a session maybe later during the day.
Sure.
With maybe just with you guys, because you can stay later.
Yeah, sure. I think it's copied. Quanser folder is copied.
Excellent. Good. Okay, keep that open for now. So
Okay.
this is good. So now you basically have the most recent Python scripts on QCar, because everything, when you're running Python, you're running it on QCar. And basically what we're going to do is use VNC Viewer to log on remotely to the Q car.
Okay.
So let's do that now, right? So actually,
VNC.
let's close this connection. I don't think you need this anymore, so let's close that.
Okay. Save.
Yeah, could cancel? Could you just right click on the NVIDIA tab on the
NVIDIA
top
tab,
left?
top left here.
Yeah, click right
So, okay, right.
and disconnect session.
Okay.
Okay. Okay, now close it.
Okay.
Okay, now you should have we have an application called Win VNC on here.
Yeah.
So that is basically your remote desktop application. So let's see if you have that loaded. Ah, there you go.
Yeah.
Yeah, enter the IP address of your Q car.
Yeah. Continue.
Yeah.
Password.
Yeah, it's the same one in NVIDIA. You'll have to get used to that because a lot of the commands we run in Python are
NVIDIA again. Yeah, so now we are inside.
cancel. That's just a display adapter thing. Yeah, don't worry about that.
Okay.
Cancel.
Cancelled. So I think there is a lag in the video.
That's what it is.
Yeah.
Everybody has that issue because we need to update our image for the newer drivers, and that'll fix it. But let's not do that now. Okay, double click on terminal.
Okay.
So inside, if you look at your documentation of Quanser, it shows you basically how to set everything up, but I'll just walk you through it.
Should
And
I
in
go
the
to
meantime,
documentation?
pardon?
Should I go to the documentation?
Sure. If you want to have a reference of how that is, that'd probably be a good idea.
Okay.
And you can open it up on your ground station PC.
Yeah.
Yeah, if you go to user manuals and yeah, go to SDCS.
User manual, we do not have.
Oh, QCar, sorry. QCar, yeah.
QCar, fine.
Yeah, user manuals QCar.
Okay. I'm already in the site QCar.
Yeah, you can go to user manual software Python.
Okay, user manual software. Okay, fine.
Okay, good. So that's your first one. So if you go down below there, if you
Okay.
go page down.
Yeah.
So this will show you basically how to use Python with the QCar. So that's one manual that you can use. The other one is the setup guide for SCCS, right? So if you go to back to your file explorer,
Okay. File Explorer, okay, file. I'm in the File Explorer. Probably we have some connection issue. Okay, fine.
yeah. So now go back to Quanser.
Yeah.
SDCS,
Okay.
setup guide, student. Yeah, so this shows you this shows you how to the commands to run and how to set up the QCar with the right libraries.
Okay.
But what I'll do is I'll run it with you manually.
Fine, fine, correct.
But at least you have this as a reference.
Sure. Okay.
Okay, you can minimize that.
Sure.
Okay, so there's a couple of things we need to do is the first one is to update. So you have the most recent cork on QCar. So that's good. So if you not open up terminal, let's just double check to see if you have the most recent Quanser Python libraries installed. So if you could type Python 3
Python 3.
and then
Okay.
-m
Dash N.
M as in Mitch
Okay.
and space PIP.
Space.
Yeah, pip
Okay. Pip.
and then list. List all the
Space
libraries.
list. Okay.
Okay, so let's see what libraries you have here. Okay, so can you go up? Just scroll up and let's go to. Yeah, keep going up. Okay, that's okay, let's look at the PY.
1.5.2.
Yeah.
Okay, so your Quanser libraries are slightly outdated, so we're going to update that. Okay, so I think maybe. So go to your user manual and I'll show you basically the command.
Okay. User manual is software. This one probably, right? Software Python user manual.
And let me see, we might need one more actually. Yeah, so because your Python libraries are just a bit outdated, we need to update that.
Okay.
So can you connect your QCar to the internet?
To the internet, yeah.
Yeah,
we
you
can
have
do
an
that.
Ethernet to your university internet, right?
Yeah, we can do that. I
So
think
just
it's
bring the QCar to your platform and just connect the Ethernet directly to the QCar.
okay, fine. You allow me to just check it.
Okay, so you're connected?
Yeah, it's connected now.
Okay, great. So open up the user manual customizing the QCar on your ground control or wherever you want.
Okay, ground control, fine. I think we already opened some. There it is. Okay, here. So user manual. Customizing.
Yeah, we need to open up another user manual. We're only have to do the updates.
Sure.
You don't need to do this up.
Customizing
Yeah, customizing the
the
QCar.
QCar. Okay.
And just go to page 13, almost right below.
Page
So
13.
this shows you how to customize some of the hardware, but also how to configure the software on the QCar. For example, if you need to update Quark, it shows you how to do that. But you have the most recent Quark already installed, but the only thing you need to do is this last portion, right? So we did the first part, we did Python 3 list, and so exactly, right? So you can type in this command, the cd
Yes,
Quanser Python.
okay. I think we can copy it. Let's try if we can paste it there, duplicate. Okay, so we are now
Yeah, ls.
here.
Okay,
Yeah.
good. Okay, so you have 2000. Yeah, and then you want to open up. Then you want to run that sudo command that was shown inside.
Okay.
It's better to look at the manual.
Yeah, this one, right? Okay, fine. Copy, then we paste. No such file or
No,
directory.
because you need to enter the date, guys. You can't just paste it and say enter.
Okay, so date, fine. What, today's date, right?
No, the date of the file that's you listed. The date is listed on 2023 329.
Oh, yeah. The Quanser hardware. Entry 23.3.29. Okay. So it's okay, right?
Yeah.
And sudo NVIDIA. Module 3.
Oh. Okay. No, sorry. That. Yeah, I know what that is. Okay. Go up again. To copy that command. So. No.
Okay.
Sorry. Your keyboard key. The up arrow.
Okay. Yeah.
Okay, and you want to do. Sudo python 3 mp just pip, not pip3. It says it's disconnected.
It is. I don't know. It's connected.
Okay. So just pip.
Okay.
Enter.
Yeah.
Okay, let's wait for that.
It is connected. It's connected. It's working. Now it's connected. Again disconnected. It's connected.
That doesn't look right. Did you try running that command again? Did you lose your connection or something, or?
Yeah, but it's still showing that it's connected.
Oh, wait, you have 2 dashes, find links. You didn't enter the right command.
Okay. Two dashes. Yeah. Upgrade. Yeah.
For upgrade and for find links, there's 2 dashes on each. And again, it says disconnected Ethernet network.
It's not. I think we should wait a bit.
Yeah, just wait for it to terminate.
Wi-Fi is also, I don't know, not stable. The Wi-Fi I got.
No, but the Wi-Fi for the Q car is connected to the Quanser UVS, which is local.
Yeah.
So you need to connect it. So the internet needs to be connected to the
It's
Ethernet.
connected. Yeah. It's correct. So I think that's okay now.
Yeah, that should be okay.
So that's on another Wi-Fi. Oh. Okay. Requirement already specified.
All right. Hmm. Yeah, okay. Um, all right. We should be okay then. So if you go to your setup guide student,
Okay,
and so now let's make sure that you have all the,
okay.
go to page 7. So this is for the
Okay.
skill activity. So if ever you want to run the skill activities, this is the command to run it. But there's some of these packages that you need, right? For example, the PYQT graph you don't have right now. So we should put that on there. So let's go ahead and do that. So what we'll do is we might as well install all the packages you need. So there's only, I think 2 or 3 more you need, because you need the PyQt graph.
Okay.
It shows you the command down below there. If you go just below, so in the Linux install.
Yeah, this one, right?
Yeah, so we're gonna modify this command slightly because there's
Fine.
one missing package, and so you can copy that, but it's
Yeah,
not
yeah,
pip3 anymore. It's
Okay,
just pip.
okay, so oh, sorry, I do not have that. You know, headphones.
I should send you an updated guide because that's.
So what happens? Okay, so when I copy it and paste it, it automatically, the enter is pressed automatically. So I think I have to type it. It's the problem. I will type
Okay.
it.
Yeah.
Okay, 0.5 fine, okay. First we have to pip, okay. Then install OpenCV Python 44046, correct. Then we have PyQt graph 0.1.2, okay.
Yeah.
0.124.
Okay, so for that one, don't specify the actual version for PyQt graph. Just
Okay.
remove the version
Sure,
to get
sure.
the latest one. Yeah, remove that.
Okay.
Okay,
And what about the PyQt? I think PyQt.
that's fine. Yeah, the rest of them are,
So I have to now
Yeah.
mat.lib,
Yeah.
mat.lib, mat.lib equal to 3.5.1.
Yep, and space, that one, you don't need to specify the version number for PY transform 3D, so you could just enter that.
PY, I don't know what's happening, we can see. Okay, fine. Cons from 3D, okay, 3D. And
Yeah.
then we have sci-fi. So it should be 1.7.3, right?
Yeah.
0.3, correct. And anything extra you want to include?
Yeah, one more, numpy.
Okay, I think I have misspelled the pi transform. So let me remove one t pi transform. Yeah, TRAN transform 3D. Okay, fine. NumPy. So any version or just NumPy?
Yes, version, so equal 1.194.4. 1.19.4.
1.4. Okay, sorry. 0.4. Okay.
Okay, your Ethernet is disconnected.
I think it's just showing. It will work.
Okay, enter.
Okay.
The connection issue.
So I don't know why it's happening. So I think I will change the position. I mean that I will connect it to another. University? No, no, I don't think so. There is this. Okay, we will try to change the Ethernet cable. I mean that we'll connect to another Ethernet cable.
Okay.
Yeah. Okay, so now it's connected to this. try again.
Oh, I think we need to tune the command you have there.
Quanser Python. Python. By G6. Okay, then not left. Not live.
Okay.
Not sorry. Isn't it? I'm sorry. Yeah. Morning. Obstruction. Obstruction.
Was there a connection issue? What went on here? Did you go up the window?
Yeah. Trace back error exception.
He's okay, go up again with your cursor, your up arrow on your keyboard.
Yeah.
Try using sudo python 3.
Okay. Think we have some problem. It's not working. Okay. Something. It's not responsive. Right. Okay.
Yeah, I think the issue wasn't the right command, right? So
Yeah, I think I have to retype the command probably.
okay, let's try one by one, guys. So go type sudo python 3.
Okay, so
You should be able to scroll.
yeah, but I think we have local problem. When I click the up arrow button, we get some beep from the robot as well. Sorry, from the car, from the
Okay.
beeper. Yeah. So I will
Okay.
type
Okay, type sudo
Python
python 3
Python 3
-m
-m.
pip.
Yeah.
Yep. And then install.
And open CV now, right?
Go first with a pyqt graph.
PYQT graph. Yeah.
Enter.
No version, right?
Just like that.
Okay.
Plain.
This one. Okay, you can go first. You know, somebody. Oh, so now we have stable condition. It was blinking with white. Okay. Oh, it's done.
Okay, okay, now let's go and install PY Transform 3D. So, yeah,
Okay.
perfect.
Transform 3D. Yeah.
Enter.
Version, no version, right? Okay. enter.
No version. Let's just try like that. That's just a warning.
Oh. Sudo this.
Okay. Okay, let's try installing NumPy.
Okay.
I don't know what the issue is with that. Maybe an issue on GitHub. Can try it again another time.
Okay. NumPy equal to 1.9.
19. 19.4.
Okay, 1.19. Okay, dot.
0.4.
Okay, correct.
Yeah.
You think so? How is choose possible? So we want to set that. Yes, उसमें फिश 3 में से नहीं है तभी पूरे जगह में से एक If you can jump to these, maybe. Committee का है इसके automatic इधर आधा आ रहा है अच्छी तरह से so
Okay. Okay, so let's see. I think the other packages might already be installed.
okay
Yeah, so you could check those out by using the sudo, the Python 3 -m list.
okay okay Python 3-m pip list, right? PIP
Yeah,
list.
list. Let's do that again and just we can see. So let's see if you're satisfying OpenCV Python.
Okay, OpenCV Python. So open, I think we do not have any.
Okay, you don't have that. Okay, how about Python?
Python is actually Python. So Python.
Okay, we'll put that.
Python
Okay,
is
so
oh,
yeah, we need to install that Python and py. Okay, it looks like we need to install. Yeah, let's just go ahead and install a whole bunch of them. Okay, try
Python is
again.
what? Sorry, what should I try?
Go back to your command window and we'll install the rest of the packages.
Okay. Yeah.
Yeah. Okay, so we got NumPy, so you can remove the NumPy and add OpenCV Python.
I think we already tried for that. Okay, so we haven't tried for that. Okay. Open CV dash Python into 4.0.46. Right?
Yeah, and let's add one more. Let's add the Pi Qt6.
Okay, so YQT6 version 6.3.1. 6.3.1.
Yeah, space and add the matplotlib.
Plotlib, okay. And plotlib and dash 3.5.1.
Okay, space and scipy as well.
Okay. Pi equal to 1.7.3. Yeah.
All right, give that a shot.
कितना सही
Okay, all right, we're rolling now.
Yeah,
So let's
now
see
we
if
are submitting.
so if we can get all these installed, then basically the next thing you do is, like in Windows, you have like environmental variables you need to set up. So the last thing we'll need to do is just set up 2 environmental variables in your bash RC file.
In this Ubuntu, right?
But yes, that's right. Yeah, but we need to
Okay.
finish installing these.
Okay.
Let's wait for
fine.
this to be
Fine.
done first, right? Well, once all the libraries are installed, we just set those 2 lines to set your
Okay.
environmental variables.
Fine.
And that's about it, I think, guys. After that, we can run a quick test to run just a single script to make sure that runs. If that runs, then we're good to go. But let's wait to make sure these all get installed properly. See, I think PY Transform 3D didn't work because we didn't have these installed before. I think that's the reason.
Installing build dependencies.
Yeah. No, yeah. We wait for this to be done,
Okay.
and this will take a while. You can also connect to the Q card directly, right? So if you ever want to just you know, do it locally, you can also do that, right? You can connect like a monitor,
Oh yeah. That would be much
keyboard and
faster.
mouse directly to the Q card, because at the end of the day, it's basically a computer.
Yeah, I think that would be much faster because this VNC viewers, I think it's too slow on it, too laggy.
There's a bit of a delay. I think the connection you have is not bad, to be honest. It's yeah, but I mean, you need to use a remote desktop because if you're driving when you're running,
Yeah.
you know, you can't have it.
Obviously.
It's for obvious reasons, right? But when you're doing stuff like this, sometimes because we're doing a remote session, then you can't really do that with a Q car, right? So we need to do both VNC and have this remote session to help you guys out. But if you're
Yeah.
doing it all on your own, like stuff like this is way faster, all done locally.
Yeah. Which if we want to run the Python stuff, so that should be run on the NVIDIA Jetson or the Q car, right? Or can we run on the Windows as well, the ground control station, ground PC?
Sorry, what do you mean?
Suppose we have Python script to we want to do autonomous or line following, suppose. So that Python script should be run on the Q car or can we run on that on the ground control PC?
On a Q car.
Okay, so we have to again come here and put our script in this NVIDIA, right? Then run it.
Yeah, if you're doing a lot of edits, you can, we have Visual Studio Code installed on your Windows PC, so you can do all your edits on your ground control PC. And then you
Okay.
can copy that file over
Okay, okay.
to the
Fine.
QCar, because doing the edits on the QCar, you can do it. But it's not the best format. I find it's easier to do a whole bunch of edits on the ground control PC using Visual Studio Code and then just copy that over.
Yeah, yeah. I think ROS will be also running directly on the Ubuntu, right?
Yeah,
Okay.
it's taking a long time.
Yeah, it's taking a long time. Probably, I don't know, but it seems like it's freezed. Yeah.
Why is it all white there? Okay, oh, that's the download.
We have 3 dots now.
Okay, maybe in the meantime, we can open up another terminal and do the environmental variables.
Sure. I should go to a bash file. I don't know whether it will be installed or not.
Yeah,
Sure. See. Yeah.
all right, perfect. Yeah, go to the very bottom.
Yeah. Okay.
Okay, so in here, you're gonna want to add 2 lines. So the first line is your Python path. So you need to send your Python path to the Python library that you copied over.
Python library.
So you copied, when you copy the files over,
Oh,
you had,
okay, okay. Fine, fine. So I think I should check it over here. Okay, so that should be cube no. Oh, so
yeah,
we have
documents,
some.
Quanser.
Okay, document Quanser. We have some good news on the second terminal as well.
Oh, great.
Libraries probably.
Libraries.
Yeah.
That's your Python, right? So you need to basically set, so you so now go to your bash RC file.
Okay, so I need this path.
Yeah.
Okay. Libraries, or should I go? I think I should go inside, right?
Yeah, that's the library you need. Yeah.
Yeah.
Yeah,
fine.
that's the path. Yeah. Okay,
Okay.
go back to your bash RC. So in here you can type, okay, perfect.
So, okay, source, I think. Yeah.
No, export.
Export.
Source will execute the commands inside
Yeah.
your bash
Fine.
RC or whatever other file. Export, then all capitals, Python path, one word.
Okay, export Python path. Okay.
Equals,
Equals.
yeah, quotation mark.
Okay. Quotation mark. Okay, sorry.
No, double, yeah, quotation, and then close it.
Okay.
Okay. Enter.
Enter.
And then you have another export command for the general Quanser folder. So export.
Okay, right here.
No,
we
it's
can
all right.
do.
It's almost
So
the
we
same.
we have to copy this line and read
No,
it, right?
no.
Okay.
Just type export.
Okay, fine. Yes.
Yeah, and then QAL, again, all capitals.
QAL
Correct. Underscore.
underscore
DIR.
DIR
Yeah, directory, and then equals,
equals.
and then quotation mark.
Yeah.
And then you can paste the path that you had above,
Okay,
just the Quanser, up to Quanser.
up to Quanser, okay,
Yeah.
yes,
Yeah, no forward slash at the end.
okay,
Remove
fine,
the slash at the end. Close the quotation.
yeah,
That's it. Save.
okay, saved. Okay, fine.
You saved it, right?
Yeah, I saved it.
Okay. So that sets up your environmental variables, and then yeah, you can do source.
Okay. So it's sourced, but I think we also had this error last time as well.
Uh, okay, could you go in the up command, your up
Okay.
arrow on your keyboard again?
Yeah,
So I think it did open CV.
hmm,
So remove the two first packages and let's just try installing the last two.
okay. OpenCV and PyQt, right?
Yeah, OpenCV, I think we got that installed.
Okay. Okay, so I should press enter, right?
Yeah.
Okay. I don't know whether we have the correct Python version or not. What do you think? Because we are getting a lot of version problems. Should be Python should be greater than or equal to 3.8.
Yeah.
Let's check what we have. So we have 2.7. So I think all the problem is because of it.
Oh,
We have to
yeah.
update the Python and then everything will be fine, probably.
Okay.
Let me check any Python 3. So Python 3 is also 3.6. So we have the below the minimum level. Python 3 should be the Python should be 3.8.
Yeah. Yeah.
So that's the only thing we have to do.
Okay.
I think we have to update the Python. Pianist, I do not remember the. Python 3.8. Okay. Let me start somewhere. Sorry, but I do not exactly remember the command.
No, I forgot as well, so.
It's happening. It's we just check here. Ground station pipeline update ground station पे तो ठीक है ground station हाँ क्यों कार ground station python is it's already 3.7.9 but
Because Python is very less, huh?
yeah वो minimum level से कम है ना तो okay so that's why we also have a ground station python available petrol so aggregate install python 3.8 Python 3-3 so we are rejected dash v so this is
Could you type sudo, sudo,
okay sudo
yeah. Apt,
app
update,
update okay oh so you want me to okay should I press enter
yeah.
okay still okay repository update repository KPA. So we got an error. So sorry, no error. Okay, error. We have one error. So error for the rows.
We don't care about password now. Okay, so if you type Python 3-v, that's what we did before. Let's just make sure nothing got,
Yeah, this.
yeah.
So we have something. Import frozen mat import. This. I think the the version is here in this line.
Yeah, so it's 3.6.9, right?
Yeah. And we should have the minimum is. Yeah, minimum should be 3.8. Okay. Should we update the Python or not?
Yeah, I think so. I'm just checking my team here.
Okay, fine.
Yeah. Let me, can you give me 1 minute? You guys are still available for a bit?
Yeah. No,
Yeah, let me get someone else, that will answer this very quickly.
okay.
Okay, we do not need to update Python.
Sorry.
We do not need to update Python. The version you have is okay.
Oh, okay, but it's in this document provided by
I
you.
know,
it's-
I know the document's wrong. Don't trust me.
Okay, great then.
Give me 1 minute here. My colleague is gonna actually join us. His name is John Pineros, and he is one of the AVRS engineers.
Oh, great.
Give me 1 minute. Okay.
तो दर्द हो गया ना वो।
So he'll join us a bit, then we'll see what's going on with the packages and stuff, because
Sure.
it's weird because I mean we were able to install some of them, right?
We can check that what we have installed.
Yeah, exactly. Yeah. Actually, in the meantime, let's do that. Let's run your let's do the list command and have the list of the libraries that are installed and what is not installed. And that way, when John hops on the line, he can bridge the gap between what the issues are. Once we do that, then we can run a quick test.
Fine.
Yeah, the test won't take long, guys. I didn't think it was going to take this long, but
No,
on the
no
upside,
problem.
I'm happy we're doing this now, not tomorrow, because this would have
Yeah.
been
Because tomorrow I was rested then.
because tomorrow we want to go and hit the ground running with running the actual
Yeah,
scripts,
yeah,
not doing
yeah.
setup and stuff, because
Yeah.
Okay.
Oh, great, John.
Hello.
Perfect timing. So we're just running the list command because as we discussed, there some libraries were we did install, but some of them we didn't. So yeah, I'll let you let's look through there. So I guess the first one is OpenCV. I think that one
Yeah.
got installed, but maybe we could double check that.
Yeah, check.
Yeah,
OpenCV.
OpenCV, there's no need to modify OpenCV. The version that comes with the car is fine. So let's leave that as is. Primarily, what you need to double check is that you have PyTransform 3D is one of the main packages that's required for one of our classes, and then PyQt Graph is the other one that's required. So I noticed you have PyQt Graph already installed as one of the packages. Were you able to successfully install PyTransform 3D?
If it is installed, I think we don't know actually what means. what we
UI
installed.
transform did not work, I think. No, that one did not work. That one
Yeah.
failed. PyQt graph was
I-
successful, but not the right version.
Let's see here.
It is 2.2 over here.
So that's
0.1.
okay. Okay. For now, let's just you have okay. So just a bit of a clarification, and I think this is a little something we have to update on our end and concern. My apologies. The lab guide requirements that you see on the right hand side are the requirements for the ground station PC, which is a different set of requirements. That is what's on the car, because the car has it's a different operating system, Ubuntu, whereas your ground station PC has Windows. So the requirements that you see on the right hand side, the versioning will be different for the car. I apologize. I know that that's a little bit of a confusing factor, and we're in the process of updating our documentation to reflect those changes. So what is important for now is let's just double check that the actual packages have been installed. Then we can take a step back and then double check that you can run some of the labs. So the first step is, you have a version of PyQt Graph, which is okay. The lab also requires PyTransform 3D. So can I see the error that you got when you did like sudo pip install and then PyTransform 3D?
I think we have to do it alone because probably we were doing multiple. So let's try it alone.
Let's just try installing one of them and don't. So when you, and that's the other catch. When you fix a specific version, so pip is the Python package manager, and some versions, like I mentioned, are specific depending on the operating system you're using. So if we fix it to the PyTransform 3D version that's in the document, that version might be available for Windows,
Yeah.
not for
Yeah,
Ubuntu.
correct. That was the
Yeah.
problem with us. Yeah. So sudo pip. What should I
Yeah.
try?
So do sudo pip install.
Pip install
Yes, and then just type the word PyTransform 3D.
transform 3D, correct?
Yes, and then just hit enter.
Okay, fine.
And so this should take a second as the key card connects online to the pip package manager.
Yeah.
So you notice here that this version is 3.4, which is completely different when that's on the document. And that's what I was referring to because of the different versions on the operating system. Yeah, again, my apologies if that's confusing. as the requirements in the right-hand side are really meant for the Windows side on the virtual environment. Okay, so the last check here is SciPy. Now, usually SciPy is installed by default when you install Windows, when you install Linux and Python itself. Let's just double check. So let's do a sudo pip install and then just type the word SciPy. SCI.
Okay, fine.
Yep. And then just hit enter. And if the requirement is satisfied, it'll tell you right away that the requirement has been met.
Okay. Yeah, it's already satisfied.
Okay, so now that we've done this, I think one of the first things we can do is have the, and I'm gonna assume just a yes, but just a quick confirmation, have the files for the hardware tests and everything, has that been passed over to the Q car? Have they been copied over or not yet?
Yeah, we copied everything, skill activities, hardware tests, applications, the
Okay.
entire resources have been copied over.
Have been copied over? Okay, perfect. Now another question, is your Q car on a physical stand so that it is not on a table?
Yeah, we are basically staying right.
Okay, it's on a physical stand. Perfect. I also noticed that the Quanser Python packages have already been installed, which is great. I will
But I don't
ask
know if
you.
they're not the most recent, because usually it's 4.13. And we did the Quark update and didn't want to install the newer ones.
Okay, it
But
didn't install the newer ones because there are older packages